everyone, and welcome to another episode of Interstigation. In today's episode of Interstigation, I will go over 2021 AIME 2 number 4. There are real numbers A, B, C, and D such that negative 20 is a root of this. So x cubed plus ax plus b. It has a root of negative 20, which means we can write it as x plus 20 because it is a root multiplied by something in the quadratic factor or in the quadratic form. So something x plus something. And of course we can have negative 21, which is x cubed plus cx squared plus d, and that would be x plus 21, that multiplied by something in the quadratic factor. Alright, and there are two polynomials that share a complex root. They share this complex root, but because we're told that the coefficients of the polynomials are real, we know that since m plus square root of m times I is a root, m minus square root of n times I is also a root for both of the polynomials. If we have two roots that are the same, means that there is a quadratic form that is the same, which means that these two are identical. Well, let's take a look at this. Well, we don't want the x squared term in this first expression, right? Well, we already have 20x squared here. How can we get rid of that? In order to get rid of that, we need that this to be negative 20. If this is negative 20, then we can have this times this. We get negative 20 squared, 20x squared, which cancels out with this plus 20 squared, 20x squared. Well, over here, let's think about it. We don't really know what it is, right? So, let's just assume that it is some number. Let's just assume that it is alpha for now. Well, let's take a look at this one now. This one does not have an x term, which means that, let's see. If we let this as beta, because we don't really know, there are two ways. We can have 21 times something x and x times something constant. Those can both make a linear term. So we don't really know from only the 0x, we don't really know what x in the quadratic is. Except that we know both of these are identical, which means that this beta over here is just going to be negative 20. Well, now, if we look at this, then we see that there is a negative 420x over here already. But we don't want any x terms, so how about this? We need to cancel it out with positive 220x, which means that this over here is going to be positive 220, which also gives that our alpha is positive 420. Now let's take a look at m plus n times I. M plus n times, or square root of n times I, that is going to be a root for x. So x satisfies this. But we also know that x satisfies negative as well. If we move this to the other side, we get plus or minus square root of n times I. We get x minus m squared. And this is going to be, well, this thing squared. Square root of n times I plus or minus. Well, plus or minus squared, that doesn't really matter because both plus and minus will squared give you plus. So that would be that. And I squared is equal to negative 1, and square root of n squared, that is equal to n. And this side is x squared minus 2mx plus m squared. And we have x squared minus 2mx plus that m squared plus n. That is equal to 0. And this expression should be identical to the one that we have here, which means we can get a system of linear equations that is negative 20 is equal to negative 2m. Obviously, that will give you m is equal to 10, and 420 is equal to m squared plus n. Because we know that m is 10, we have 420 is equal to 100 plus n, to give us n equals 320. Let's take a look at our problem. The problem asks for m plus n. Therefore, we want to find the value of m, which is 10 plus 320, which gives us our final answer of 330. Thank you for watching this episode of Interstigation, and a little bit of sneak peek. I will be recording the solutions for AMC 10B and possibly 12B once they come out and discussion is allowed. So stay tuned for that. And I will not be covering AMC 10A or 12A, but you can check out Power of Logic's channel for that, and I will link that in the description below. So thank you for watching this episode, and goodbye.